Okay, new topic, radians. We're looking at radian measure, so make some notes on our lesson objective and heading. So hit pause when you're ready, hit play again. Okay, so I chucked this in from, I don't know, it might have been year 8 or year 9 you'd have done this investigation into circles, and you'd have been looking at the relationship between the diameter of the circle and the circumference of the circle. Now you know what that is because you know what the formula for the circumference of a circle, well, I hope you know what that is. But at this time you would have drawn some circles and then you would have measured the diameter, and then with string you would have tried to stretch it around the circle to see how many times the diameter would fit around the circumference. And I would have asked you to guess how many times, and hopefully you would have said about three and a bit. You do get some strange answers. So anyway, when we do it, you take the diameter out and you stretch it around once, twice, 3 times and a bit. Okay, it's approximately 1/7. So the circumference is 3 and a bit of the diameter. That 3 and a bit we know to be pi. So circumference is pi d, or 2 pi r in terms of the radius. So we can stretch the diameter around the circumference of a circle 2 pi r times, and 2 pi r is 360 degrees because that's the 360 is the circumference of the circle. Okay, so don't make any notes on this. You know all this. This is common knowledge to you. What we're going to look at is how many times you can stretch the radius. We'll have a look at that now. Okay, so up till now we've been measuring angles in degrees. We've been measuring the circle, or angles around a point, as 360 because we go around, which is 2 pi r. Now it's that's very useful, but radians were invented because they're a more useful tool for measuring the angles around a circle. So I'm going to draw a semicircle. It's not the prettiest semicircle in the world. Okay, so up to now you've been used to measuring angles around a point, angles in a circle, using degrees. But there is another way of measuring angles in a circle, and that is using radians. So if we have a circle here, we're only going to look at the radius. So in that semicircle there, wow. So in this semicircle here, we're going to look at now we've always used degrees to measure the angles around a point or angles in a circle. So we use 360 degrees around a circle, 180 for half a circle. But there's another way. We can actually measure the number of radii around a circle. And the number of radii around a circle, if we start at the center of the circle here, the number of radii are the number of radians that we can go around the circle. Now if we just look at the top half of the circle, a semicircle here, how many radiuses can I fit around the top half of the circle? What do you think? You can fit 3 diameters around a full circle. How many radiuses, well 3 and a bit, can I fit around here? So if I draw them, if I draw one radius there, it's a radius there, and I've taken the radius, that's the radius around there, so that's 1 radian. 1 radian there. Let's do another one then. So we've got a second radian there. So that's my radius. That's my second radian, another radian, and that's my radius I've been able to stretch around. I think I can stretch one more in there, one and a bit. So if I put it in there, that's my third radian. So that's the radius there, and the radius is stretched around, and there's a bit left over. So that's another radian. 1, 2, 3 radians. 1, 2, 3 of them, and a bit. So that means 3.14 radians. Tell you what, let's just write radians. Is equal to 180 degrees. And that 3.14 is approximate, but exactly pi radians equals 180 degrees. This is a different way of measuring the number of degrees in a circle. Okay, so we could say 90 degrees is equal to pi by 2. 45 degrees is equal to pi by 4. And we could say 360 degrees is equal to 2 pi. So I think this time you need to make notes. I'd sketch the circle, maybe just sketch the semicircle, and then make these notes on the side. So hit pause, make some notes. When you're ready to move on, hit play again. Okay, you need to be able to convert between degrees and radians and vice versa. Now we know, we're now quite good at recognizing that pi radians equals 180 degrees. So if we get a question like so: convert the following angle to degrees. 7/8 pi. Let's put an example here. Convert it into degrees. We got 7/8 pi. That's going to be equal to, we know pi equals 180, so we simply substitute 7/8 times 180, and we put that in our calculator, and we should get 157.5 degrees. 7.5 degrees. So I want you to check that, make sure it's correct. When you're ready, hit play again, and we move on to another example. Okay, similar sort of thing with this example. You know that pi radians equals 180 degrees. You can write radians as a little c at the top there, equals 180 degrees. So we got convert 4/15 pi into degrees. So I'm going to leave that with you. You can do that. You have 10 seconds to do that, and then you can have a look at the solution here. Four over 15 pi, we know pi equals 180 degrees, and we simply substitute 4/15 times 180, which is going to be equal to, when you work it out on your calculator, and you should get 48 degrees. Oops. Okay, make some notes, and when you're ready, hit play again. Very good. Okay, so this time we're going to go in the opposite direction. We're going to convert from degrees to radians. Okay, now you know that 180 degrees is equal to pi radians. That means 1 degree is going to be equal to pi divided by 180. So let's have a look at this example then. Convert the 150 degrees into radians. So if we write example here, 150 degrees well, if I put here 1 degree is equal to pi divided by 180, 150 is going to be equal to 150 times pi over 180. So 150 times pi over 180. The zeros cancel. Just trying to see what goes into 15 and into 18. 3. So if I change to a blue pen for my cancelling, 3 goes here 5 times and 3 goes here 6 times. So that leaves me with 5 over 6 pi. Pi radians. Okay, so hit pause, make some notes, and we'll look at another example. Okay, another example. Now we're going again degrees to radians. Now you know that 180 degrees is equal to pi radians. So 1 degree equals pi divided by 180. So if we look at our example, 110 degrees, 1 degree equals pi divided by 180. Therefore, if we multiply it by 110 on this side, we've got to do the same on the other side. The zeros cancel and nothing goes into 11 and 18. So that leaves us as 11 over 18 pi. Alright, my 11 there. I already wrote pi there. Good. So hit pause, make some notes. When you're ready, hit play again. I'll just change that, make it more presentable. 11 divided by 18 pi. I did it again. Can't believe that. Should be 11 over 18 pi. I'm sure I'm going to get it right this time. 11 divided by 18 pi. Good. Hit pause, make some notes, and when you're ready, hit play again. Okay, and with practice then we'll start to get used to using radians. Some of the radians that you need to recognize as degrees, we know that pi equals 180. What about pi by 2? That's going to be 90. Pi by 3, 180 divided by 3, should have 60. Pi by 4, 180 divided by 4, divide by 2 and divide again, 45. Pi by 6, so 180 divided by 6 give you 30 degrees. Hit pause, make some notes on those. You can either use it in that style or you can use more of a table style. That's entirely up to you. And another thing then is you can calculate angles in sine, cos, tan using your calculator. But first you've got to convert your calculator into radians. Okay, so if you've got your calculator with you, what you do is you press shift, don't hold it down, just press shift, and then you see setup across the top there next to menu, and then you'll see number 2 says angle unit. If you hit 2, then you have degree, radian or gradient, and if you hit 2, gradient we'll never use. If you hit 2, your calculator is now in radians, and you can calculate things like sine of pi or sine of pi by 2, and say you could calculate the sine of 3.14 to see if that approximates to pi, or cos or tan of those. So that's worth playing around on your calculator with then. Okay, in the exam you've got to be careful when you're working. Are you working in radians or are you working in degrees? So you've got to be very, very careful which one you're working with. Good. Moving on. Sine, cos and tan. Now we've drawn these, we drew these last year a number of times, and we went from well, here we're going from minus 360 to plus 360, but we need to be able to draw these in radians. Now that's 0. 180 is pi minus pi, so that's going to be minus 2 pi. It's going to minus 270 minus 3 over 2 pi. That's minus pi by 2. 0 stays the same. And then you just fill those in then. So that's pi by 2, pi, 3 over 2 pi, and then 2 pi. And it's the same then for cos and tan. So I think it's useful for you to sketch these three curves. It gives us familiarity again. It allows you to remember what they looked like from last year, and gives you some notes as well. Good. So hit pause, sketch them. I think they've got good colors there. You might follow that color scheme, and when you're ready to move on, hit play again. We'll have a look at one more example. Okay, so this example says sketch the graph of y equals cos x plus pi. So first things first, sketch the cosine, cos of x. And if we sketch cos of x, it's a mirror in the y-axis, looks like that. If we add pi to it, it's within the function, so it's going to shift along the x-axis. Okay, so everything shifts, because it's plus, everything shifts to the left. So if I change color, let's see if we can use blue. So that's going to end up over here somewhere, because it's going from 2 pi to pi. That is going to end up down here. Oops. If I make a cross there, that's shifted across there. And the pi down the bottom here is going to end up here. So we'll have a curve that looks like that. Oops. It'll pay you to sketch it again. Okay, like so. I think it's better in the second diagram. There you go. So it's shifted to the left, pi radians. Hit pause, make some notes. I'm gonna remove that blue line. I think it's best you draw the graph again as in the PowerPoint. And it's time for you to do some work for me. So hit pause, make some notes, and it's time for you to do the questions. And questions for you, questions 1 to 8. On question 1, I can't say go down the left hand side of the page. You just wouldn't have enough questions. So maybe 1A, C, E. And if you fancy doing anything extra, you may. And same thing for B, sorry, for number 2, A and C maybe, 3, A, C, E again, and so on. Good luck.